Hello, Kaushik.
Yes, sir.
This is your first lecture, right?
No, sir, not possible.
What all we did before?
Last month we did some question regarding
Okay, we did some question, right? Numericals.
battery circuit. That one.
Sorry, come again. I cannot hear you properly.
Sir, last month I attend your class. After some reason, I can attend your class. There we did some numerical regarding that battery charging circuit. Some numerical
Okay.
and that
Okay. So how
transformer.
many class you attended?
Attended near about 1 week class.
1 week. Okay. So this month you are going to apply for electrical, right?
Yes, sir. Last month I appeared, but exam was not good.
Last month means in September you appeared.
September I appeared. So this month it will be not. The next month I will book for the again because exam was not good. The
But
guarantee
the
I
question paper was not so difficult, right? In the September,
got
the question
difficult.
was okay.
Question was okay, but I was not prepared that much.
Yeah, okay, no problem.
Motor MEP general it was good, but electrical was not that much good.
Okay, no problem. This time we are going to get the electrical as well, don't worry. So first I will build up some basic. Okay, just tell me if you have done all this with me. If not, then I am going to do all this. Have you done this with me? No, right?
No, sir, I have not done this.
Okay. So first of all, how do we produce, on the basis of what law we are producing the electricity on board the ship?
Sir, alternator.
Hmm? Your voice is not so clear. There is some problem. Okay, no problem. But you can hear me
Hello,
properly,
sir.
right?
Yes, I am hearing you.
Okay, then I'll tell. So on the shipboard, we are producing the electricity by the Faraday law of electromagnetic induction.
Okay,
What
sir.
is Faraday law? What is Faraday law? So shipboard
And
power is generated by using the prime mover. What is prime mover here?
prime mover, sir, alternators.
Generator, right? Your generator engine is a prime mover. And to that, a alternator is attached, right?
Yes, sir.
And they are working together to generate the electricity. For this alternating generator is used on board. So, and we are using the alternating generator. The generator work on the principle that if there is a relative motion between the conductor and the magnetic field. So suppose these are your magnets, north pole, south pole. So magnetic lines of force will travel here, right? Like this. And if a conductor is placed in the magnetic field, and if this conductor, either this conductor is rotating or your magnetic field is rotating, it is going to induce a EMF, electromotive force, and this EMF is directly proportional to d phi by dt, that is rate at what it's cutting your flux. So this is your north pole, this is south pole, this is the conductor. So the fast you are going to rotate the conductor, it is going to cut more number of this magnetic line of forces in per minute, right?
Yes,
So
sir.
suppose it's moving at 60 rpm, so it will cut in 1 minute only 60 times. But if it will moving at 90 rpm, it will cut at per minute 90 times, right? So your electromotive force will increase. Understood this much? So by this law, we got to know that if something is rotating inside a magnetic field, if a conductor is rotating, not something, if a conductor is rotating inside your magnetic field, you will generate a EMF, and EMF is your current only, right? So, but we don't know the direction of this EMF, right? It is only telling us there is a current generation, there is a electromotive force generation, but what will be the direction? That we get to know by the Fleming right hand rule. What is Fleming right hand rule? What is Fleming right hand rule? Sometimes this is your oral question also, they ask directly, tell me the this Faraday law of electromagnetic induction, tell me the Fleming right hand, Fleming left hand rule. Okay, Fleming right hand rule, sometimes we call it as a generator rule also. So this is your right hand. When you are going to stretch your thumb, forefinger and index finger parallel to each other, okay, the EMF or current produced by the Faraday law, its direction can be found out using the Fleming right hand rule. The right hand rule is held with the thumb, index finger and middle finger mutually perpendicular to each other at right angle as shown in the figure. The thumb is pointed the direction of the motion of conductor. So your thumb is showing in which direction your conductor is moving relative to the magnetic field. First finger is pointed the direction of the rotation of your magnetic field, that is from north to south, and your second finger will represent the direction of induced current in the conductor. So this is how we can find out the direction of induced current in the conductor. Understood?
Yes, sir.
Okay. So what is Fleming left hand rule now? If that was the right hand. So left hand rule, sometimes we call it as a motor rule also. Now instead of right hand, you are going to stretch your thumb, index finger and middle finger mutually perpendicular to each other of your left hand now. So whenever a current carrying conductor, so now current is flowing in a conductor and it is placed in the magnetic field. The conductor will experience a force which is perpendicular to the both magnetic field and the direction of the current. According to Fleming left hand rule, if the thumb, forefinger and middle finger of the left hand are stretched at the to the perpendicular to each other, similarly like this, but of your left hand, and if the forefinger represent the direction of your magnetic field, the middle finger will represent the direction of current and thumb represent the direction of the force acting in the conductor. Thumb represent the direction of thrust on the conductor, forefinger represent the direction of the magnetic field, and whereas your middle finger or center finger represent the direction of current. I hope this much is clear.
Yes, sir. Clear.
Next thing, sometimes they are asking in the oral also, what are the safeties provided in your main switchboard? So what all safety you can think in the main switchboard is provided? No input. Okay. So these are the safeties provided in your main switchboard. Ebonite rod. What does ebonite rod means? So you must have seen the black color handle is attached to your main switchboard, right?
Yes, sir.
That is made of ebonite. Okay. But then what you have? Rubber mat in front of the switchboard.
Yes, sir.
And normally its thickness is 15 mm. Next is dead front panel. What does dead front panel means? What does this mean? Dead front type switchboard?
There is no current.
That means, so you must be seen on board. If this is a panel and this is the switch provided on the top, this is on position, this is the off position, right? If your switch will be like this, right? So can you open this cabinet when this breaker is in on position?
No, sir. No.
No. So it will only open when you are going to put it into the off position, right? So that is known as dead front. So means now your front of the panel is dead. There is no current is flowing in the wires. Now you will be able to open the switchboard. And behind the switchboard also you must have seen this is your bulkhead. Switchboard is little bit away from the bulkhead, not just directly mounted on the bulkhead, right? So this is the regulation. They have to provide the 0.6 meter gap behind the switchboard. Then you have the fuses, circuit breaker, arc fault indicator, panel doors are earthed, and you must have realized there is no steam and oil pipeline passing in the vicinity of the main switchboard. Then there are the trips provided: under voltage relay, reverse power trip, preferential trip, overcurrent trip. All these are provided in your air circuit breaker, right?
Yes, sir.
And then there will be a short circuit trip also. And why the actuates provided in the ACB? So that it can do the quenching of the arc. Okay. So next is what all safety is provided in the emergency switchboard. So all the safeties are same like your main switchboard. All are the same, and it should be installed as near as possible to the emergency source of electrical power. EHP should be able to supply during the normal operation from the MSB. So your ESB in the normal, when everything is good, it is getting power from your main switchboard with a interconnector. No batteries should be fitted in the same place and should be located in the uppermost continuous deck, easily accessible from the open deck. These are the requirement for your emergency switchboard. Next is what all equipment is getting power from your emergency switchboard. What all equipment is getting power from your emergency switchboard?
Sir, emergency air compressor.
Hmm.
All of the emergency equipment. One of the blue oil pump or
But they are asking in the oral. You cannot say, right, all the emergency equipment. You have to write
emergency,
down, right?
emergency light, emergency air
Hmm.
compressor, uh, one of the generator blue oil priming pump,
Very good.
sir, and one of the sir cooling pump.
Hmm.
And sir, one of the sir for the generator, main generator one of the say, fuel pump also. supply a circulating pump also connected to the emergency
Supply
supply.
and circulating pump, right?
Sir, sir, navigational equipment connected to
Navigation
the gyro.
equipment. Okay, I'll just tell you what all things are connected. You can just see. So you are connected to the emergency light, then your navigation system, then your steering gear motor, emergency steering gear motor, right?
Yes, sir.
Emergency fire pump, emergency air compressor, battery charging unit, right?
Yes, battery charging. Yes, sir.
Then fire detectors and alarm unit, radio equipment, daylight signals, lamp and whistle. Next is your navigation equipment, then general alarm, one supply pump, circulating pump, one supply pump for your generator, and priming pump, right? Low boil priming pump. Then you have the watertight door. So do you have the watertight door on board the ship?
Watertight door.
Yeah, watertight door. Have you seen?
Yes, sir. When fire alarm is activated, it will close automatically.
So you are sailing on what kind of vessel?
Sir, of tankers, chemical tanker.
What is the location of this watertight door? Can you tell me the location?
Sir, okay. Fire door and watertight door, so different. Sir, watertight door, sir, the accommodation, the take to the accommodation space.
You don't have the watertight door on board your ship. No watertight door on the chemical tanker, okay? You will only find the watertight door either in the passenger ship or in the container vessel. Have you sailed on container ship?
No, no, no. The tanker.
Okay, only tanker. Then you don't have the watertight door. For which company you are sailing?
Sir, fleet management, sir.
Fleet management. Okay, from starting only.
Yes, sir. Starting.
Okay, okay. Clear?
Yes, sir.
So what is the emergency switchboard? It is a switchboard which distribute the emergency load. That power is supplied from the emergency generator during the main power source failure. It normally has two sections. One section is for 440 for running your machineries, and 220 for your lighting and all, or small motors. Under normal condition, 440-volt supply is taken from the main switchboard through a circuit breaker. When the main power is lost, the circuit breaker is tripped, Emergency generator come into the action and supply the power to the another circuit breaker. An interlock is provided to prevent the simultaneous closing of both the breaker. Both main and emergency generator may be running simultaneously. That is why they have provided a interlock between them. So what is phase single phasing? What is single phasing?
So in three phase connection, if one phase is get distorted or disconnected, that is
Yeah,
known
as you can see in the diagram also. Can you see this phase is getting break? So this is known as the single phases. Can you look at this diagram and tell me in what connection this motor is connected? This is star connected or delta connected?
as the
This
delta
is
connection.
delta connected. Very good. So the three-phase motor must be connected to the rated voltage load for proper working. If due to the some reason one phase of the motor get disconnected, can you see here? The motor phase got disconnected. The motor will continue to run with the active two phase. Why they are continue to run with the active two phase? Because we have the insulated earth system on board the ship, right?
Yes, sir, insulated, neutral, thing, the one thing.
That I will also tell you. Just wait for some few more minutes. I will tell you that also what is insulated and what is neutral. This is called single phasing. So if single phasing is occurring, it might be possible. It not, it might be your motor is going to keep on running. But if you are going to stop this motor and you're going to start it again, is it going to start?
No, sir, it will not start.
It will not start, but it only depend on your luck, right? If it is stopped at the right position where two phase is able to rotate it slightly, then it can start. But if you are not lucky, then it will not start. Okay. If the three phase motor is running and then one of the phase get disconnected, the motor will continue to run, and suppose you are taking the engine room round, how you will get to know this motor is single phase? Suppose this is your seawater pump motor, main cooling seawater. How you will get to know in the round that this motor is single phased?
Sir, it will take, sir, more current and the motor will heat up.
Very good. It will take more current and motor will going to get heat up. And plus your pressure in the gauge will be the less, right? Because it is revolving at the reduced speed, right?
Yes, sir, it is.
Very good. And you are going to feel some vibrations also. However, depending on the loading condition, the motor may or may not start on two phase. That is what I said. It depends on your luck. Single phasing is not desirable for proper operation of the induction motor, and appropriate measures should be taken to protect the machine from the single phasing. So what can be the cause for the single phasing? What all can be the reason? What all can be the reason for single phasing?
Any other wiring, wiring system, three-phase.
Hmm.
Sir, it can be causes to damage in wire. It can one of the reason.
Okay.
And motor having some insulation protection. If insulation get deteriorate, that time also can causes the earth fault of
Hmm.
COB.
Hmm.
These two.
Okay. We are going to see what all can be the reason for single phasing. Just give me a moment. I'll just come back. Okay, so one of the contactor for the motor is open circuit, or one of the fuse is blown. In the all three phase, we have one fuse, right? So suppose the motor was running and this fuse is blown. So this is as good as single phasing, right? Or one of the contactor is open, or the wrong setting of the protection device on the motor. So suppose you have put the wrong value of the fuse, or relay contact is broken or damaged. These all can lead to the single phasing. So next is, what will be the effect of the single phasing? As you said correctly before also, there can be the there will be the reduce in the motor speed. It operate at uneven torque and produce a humming noise and sound. It is going to vibrate. It is going to overload the. It may going to go the overload of the generator, not necessarily. The motor arranged for the standby and automatic starting. The motor will not be starting, or it will, if it will start, that is your luck. And if the overload relay is provided fails to function, then the motor may is going to burn. Okay, these all can be the effect of the single phasing. So now tell me, what all protection are provided on a motor? What all protective devices are provided on the motor? So these are the protection provided on the motor. First one is overload relay. All the three phases of the motor are fitted with an overload relay. If there is an increased value of the current, so they measure the value of the current. If the current value is increasing, then this relay activate and automatically the motor trips. Second one is thermistor. They are used along with the electromagnetic relay inserted in the winding. Can you see in this figure? They are inserted inside the winding.
Yes, sir.
They sense the increase in the overload relay temperature. So what they are sensing? They are sensing the temperature in the winding. And when the temperature is high, a signal is sent to the amplifier, and we turn this temperature into the current signal, and it is going to operate the this coil, and it is going to trip your motor. And then finally you have a bimetallic strip. I hope you know what is bimetallic strip, where they are using two
Double XL.
different type of metal, right? And on the basis of temperature difference, they are going to bend, right? And they are going to open the circuit. Clear?
Yes, sir. Clear.
So next is, what is insulated earth system and what is neutral earth system? So an insulated system is the one that is totally electrically insulated from the earth. So what does it mean? Suppose this is your generator and this is the neutral point, right? And this neutral point is not earthed anywhere. This is known as insulated. So you have kept the earth as a insulated. What is neutral earth? This point you are going to ground. Okay, understood this much?
Yes, sir.
An earth system have the supply neutral point connected to the earth. So here the neutral point is connected to the earth, and in the first one the neutral point is insulated. Shipboard with low voltage system like 440 AC are normally insulated from the earth. So when you are sailing on the ship, like your oil tanker, you are, they must be low voltage, right? You are not generating more than 1000 volt, right?
Yes, sir.
So you are sailing on the low voltage ship. So on your ship, the system will be like the insulated earth system. Similar system ashore, if you are going to see similar 440 volt system ashore, they are using the earthed system. Why? That we will see later. But if you are sailing on the high voltage ship, like your container vessel, they are most of them are high voltage now. So they are using a system known as neutral earth resistor and through a high impedance transformer to limit the earth fault current. The priority requirement on board the ship is to maintain the continuity of the electrical supply. So if you are going to use a system like earth neutral system, what is going to happen? Suppose this was your generator, this was the neutral point and you earth it, and here one earth fault occur at the motor. So the large current will start flow from here, right? Because the current take the less resistance path, right?
Yes, sir.
And when large current will flow, your motor at the overcurrent relay, it is going to open the breaker, right? And if this breaker is not going to open, your generator is going to get overloaded. So our first aim on board the ship is to run the machinery even with the single earth fault, because suppose this is your steering gear motor, and because of the single phase your motor is tripped and you are in the maneuvering water, so you are in deep trouble now, right? So that is why our first priority on board the ship is to keep the equipment running. The priority requirement on board the ship is to maintain the continuity of the electrical supply to the essential equipment. What are the essential equipment? Like your steering gear motor. In the event of the single earth fault, they should keep on running. The priority requirement assure is to the immediate isolation of the earth faulted equipment, which is automatically achieved by an earth seed system. Understood?
Yes, sir.
Okay. Now look at this diagram. There is one earth fault is occurred at point number B and another occurred at point number C. Now we will see what they are saying. An earth fault is due to the break in the insulation. So if there is a break in insulation, there can be a earth fault, right? Now this insulation breakpoint can touch anywhere as at B, allowing the conductor to touch the hull. Can you see at the B? Now it is touching the hull or an earthed metal enclosure. A short circuit is fault is due to the double break in the insulation. So short circuit will only occur when there will be one more earth fault, because this system is having the insulated system, right?
Yes, sir.
So with single wire, there is no potential difference getting generated, right? So it is not doing any harm. So a short circuit fault is due to the double leak in the insulation as at C, allowing both the conductor to be connected so that there is very large current bypass or short circuit the load. The size of the fault current that will occur depend on the overall impedance left in the circuit under the fault condition. What is significance of earth fault? If a single earth fault occur on a live line of an earthed distribution system, it would be equivalent to the short circuit, right? And fault across the generator through the ship's hull. The resulting large fault current would immediately cause the line protected device, such like your fuse or circuit breaker, to trip out the faulty circuit. The faulted electrical equipment would be immediately isolated from the supply. However, the loss of the power supply could recreate a hazardous situation, especially if the equipment is like your steering gear motor. The large fault current could also cause the arcing damage to the fault location. In contrast, a single earth fault A, if there is only single earth fault occurring, can you see here there is only single earth fault? In contrast, a single earth fault occurring at point A on the line of the insulated distribution system will not cause any protected device to operate, and the system would continue to be function normally. This is important point. Equipment continues to operate with single earth fault as it does not provide a complete circuit, so no earth fault current will flow. Now, if the second earth fault occur at B, so can you see there is one more earth fault is occurring at B? Now, if the second earth fault is occurred at B on the another line in the insulated system, the two earths fault together would be equivalent to the short circuit fault, and the result in large current would operate the protection device and cause the disconnection of perhaps essential service and creating the risk to the safety of the ship. An insulated distribution system therefore required two earth faults on two different lines to cause the earth fault to flow current. In contrast, in earthed distribution system, require only one earth fault on the line of the conductor to create the earth fault current. An insulated system is therefore more effective than the earthed system in maintaining the continuity of the supply. Hence, it is the adoption for the most of the marine electrical system. So understood why we are using the insulated earth system and why we are not using the earthed insulated system.
Yes, sir.
Okay. So now the question you should ask me is this one. Can you read these two lines and can you see what should be your question? Just read both of them. Start from the shipboard low voltage.
Yes, sir. For the source system, why we using that not the ship. For ship, so you can understand that if it is single arc fault also there, then machinery will run. For source system, it is, and
So
this
here
why
it
this
is.
high
Hmm.
in high voltage ship, there why we using this neutral earth system? Why not this
So this,
440?
yeah, this is what you should ask me, right? In the high voltage ship, why we are using the earthing system? Why we are not using the insulated? Yes,
Yes, sir. Because
because if we are
I
going
think
to
that
use
there
the
will
earthed system, what is going to happen? One single earth fault is going to trip your motor, right? So what about your steering gear
yes,
motor now?
it will trip, sir. If
It will
single arc
trip.
fault will happen.
Yeah. Now we are going. Obviously, we are doing is this in the high voltage system because humans are also there, and human if they are going to touch, and if there will be potential difference like that, human can get a severe shock. That is the reason, and we are going to see along with it how they are maintaining the supply to the essential equipment now. So in high voltage system, like your 3.3 kV or above, or 1.1 kV or above, on board the ship are normally earthed. So now they will be normally earthed. Can you see here? They have put the neutral earth resistor and they have earthed
Yes,
the system. Okay. Such system are usually earthed by a resistor connecting to the generator neutral to the earth as shown in the figure. The ohmic value of the earthing resistor is usually chosen so to limit the maximum earth fault current to not more than the generator full load current. So you have to put this resistor in such a manner that the resistor will not increase the generator full load current. Such neutral earthing resistor is usually assembly from a metallic plate. The use of such earthed high voltage system means that if there is a single earth fault will cause the current to flow in the neutral connection wire and this monitored by earth fault relay, and this is going to give alarm and trip your generator. Okay, it is going to. Do you remember Tony in the last classes?
sir.
When you did the classes last week, a student Tony was there. Do you remember?
No, Tony is not there. I did with this Lizo and all that time.
Lizo and Tony were together, right? Okay, maybe you are not remembering. Yesterday he got the result and he passed the exam. Just now he texted me that he cleared the electrical written examination. I think yesterday only you got the result, right?
last month result. Okay.
Yeah, they gave in August.
Yes, yes.
Okay.
In that, sir, high voltage, if there will be there, if arc fault happen in this particular machinery, there also can be the strip system will be there for particular cell like heavy motor like VT and all that time.
Yeah, we will see. We'll see this now how we are doing. So next is what about the important machinery? If see something like your BT and all, single arc fault is going to trip your BT. Okay, but the important machinery is like your steering gear. So how they are what they are doing for steering gear motor? So certain essential load, example your steering gear, can be supplied via a transformer. So they are reducing from 3.3 kV to 440 volt using a transformer. With this secondary unearthed to maintain the security of the supply. So this transformer secondary winding is not earthed now. So this became a separate circuit, right? Now if there will be a single earth fault, this machinery is not going to stop. Understood what they are doing for the essential machinery?
Yes, sir, understood, sir.
Remember this one they might can ask in the oral. I'm not following the electrical oral question answer, okay? But I feel like this is the important thing. So there can be a earth fault monitoring lamp. Have you seen the earth fault monitoring lamp in your ECR?
Yes, sir.
So if you can see in the figure, first lamp is connected to the L1, second is connected to the L2, and third is connected to the L3. And on the bottom, they have the common point, and this common point is connected to the earth via a test switch. So how to measure the earth fault? Each indication lamp in a three-phase system are arranged as you can see in the figure. When the system is healthy, that is no earth fault is present, then the lamp glow with equal the lamp glow with the equal brightness. When you are going to press this test switch, you are going to get the equal brightness. If an earth fault occur on the line, the lamp connected to that line goes dim. So suppose if there is a earth fault in the line number L3, can you see this light is getting dim or extinguished? It might be possible the bulb will not lit only. The other lamp experience an increased voltage, so will glow brighter than before. Earth indication lamp have been the most common method used for many years and being inexpensive in insulation, which is easy to understand. Their major disadvantage is that they are not very sensitive and they will fail to indicate the presence of high impedance earth fault. This has led to the development of the instrument type earth fault indicator. What is now you are seeing on board your ship. There is a dial gauge kind of thing, right? And in this, the indication is from infinity to zero, right?
Yes, sir.
This is the development. So I think this is enough for today. I know electrical is little bit difficult for the marine engineers, right? So I'm not going to overburden you. So I'll stop this lecture today, and tomorrow we will start numerical. Okay.
Okay, sir. Okay, sir.
And you are having the added advantage since you are the only one. So obviously the focus will be on only on you.
Thank
Okay,
you, sir.
Kaushik. See you tomorrow, same time. Okay.
Okay, thank you, sir.
Thank you.